Top 25 CNC Machinist Interview Questions and Answers. In this video, we will explore the top 25 interview questions commonly faced by CNC machinists. These questions are designed to assess both technical skills and practical experience in the machining industry. We will also provide detailed answers and insights, helping you prepare effectively for your next interview. Whether you're a seasoned professional or just starting, this guide will enhance your confidence and readiness. 1. What attracted you to a career as a CNC machinist? A passion for precision and technology drew me to a career as a CNC machinist. I have always been fascinated by how machines can create intricate components with exact specifications. The ability to transform raw materials into functional parts excites me. Additionally, the continuous learning aspect of this field, including staying updated with new technologies and techniques, keeps me motivated. The satisfaction of producing high-quality work while adhering to strict tolerances is rewarding, making every project a unique challenge that I look forward to tackling. 2. How many years of experience do you have operating CNC machines and with which machine brands? I have over 5 years of experience operating CNC machines, primarily with brands such as Haas and Fanuc. My journey began in a small manufacturing shop, where I learned the basics of CNC operation and programming. As my skills progressed, I had the opportunity to work with various machine types, including vertical and horizontal machining centers. This experience has provided me with a solid foundation in both setup and operations, allowing me to efficiently produce high-quality components while adhering to tight tolerances and deadlines. 3. What types of CNC machines and controls are you most comfortable working with? Fanuc, Haas, Siemens, etc. I am most comfortable working with Fanuc and Haas CNC machines. My experience includes operating vertical and horizontal machining centers, as well as CNC lathes. I appreciate the user-friendly interface of Fanuc controls, which allows for efficient programming and operation. With Haas machines, I have developed a strong understanding of their setup and maintenance processes. I also have familiarity with Siemens controls, which I used in a previous role, enhancing my versatility across different types of equipment in a production environment. 4. Can you describe your experience with reading blueprints and engineering drawings? In my experience as a CNC machinist, reading blueprints and engineering drawings is essential for understanding specifications and tolerances. I have developed the ability to interpret various types of drawings, including orthographic projections and isometric views. This skill allows me to visualize the final product and understand the dimensions required for machining. I pay close attention to detail, ensuring that I grasp all annotations, symbols, and notes. This practice helps me accurately set up machines and achieve precise cuts, which is crucial for meeting quality standards in production. 5. What is your experience with shop mathematics, such as trigonometry and geometry, in machining tasks? In my experience as a CNC machinist, shop mathematics plays a crucial role in ensuring precision and accuracy. I regularly apply geometric concepts to determine angles and dimensions required for machining operations. Trigonometry is particularly useful when calculating tool paths and offsets, especially for complex shapes. I often use formulas to derive critical values, which helps in setting up fixtures and tooling. Regular practice with these mathematical principles has enhanced my ability to troubleshoot issues and optimize machining processes effectively. 6. Describe the process you use for setting up and operating a CNC machine. Setting up and operating a CNC machine involves several key steps. First, I gather all necessary tools, materials, and documentation, including blueprints and setup sheets. Next, I install the required tooling and fixtures, ensuring they are secure and properly aligned. Once the machine is loaded with the material, I input the program and set the work and tool offsets. I perform a dry run to verify the program's path and make necessary adjustments. After confirming that everything is functioning correctly, I start the machine, monitoring it closely for any anomalies during the initial runs. Regular checks ensure consistent quality throughout the process. 7. How do you go about calculating feeds and speeds for different materials? Calculating feeds and speeds begins with understanding the material's properties, such as hardness and machinability. I refer to the manufacturer's recommendations for the specific tool being used, which often include optimal surface speeds, SFM, and feed rates, IPM, for different materials. I adjust the spindle speed based on the diameter of the tool and the desired surface speed using the formula. Text, RPM, equals, frac, SFM, times 12, pi, times, text, diameter. After determining RPM, I calculate feed rate by considering the number of flutes on the tool and the desired chip load per tooth. This ensures efficient cutting without overloading the tool. 8. What steps do you follow for confirming machine calibrations and zero referencing before a job run? To confirm machine calibrations and zero referencing before a job run, I start by checking the machine's calibration settings against a known standard or gauge. This includes verifying axis movements and ensuring that the tool offsets are accurate. Next, I perform a reference point return to establish a precise zero position for the workpiece. I then use dial indicators or other measurement tools to ensure the tool is correctly positioned. After confirming these steps, I run a test cycle without material to check for any discrepancies. Finally, I document the calibration status for future reference. 9. Tell me about your experience with G-code programming or editing machine code to fit unique jobs. I have extensive experience with G-code programming, using it to create custom machining operations tailored to specific job requirements. My proficiency includes writing new programs from scratch as well as editing existing ones. For instance, I have modified G-code to optimize machining paths, reduce cycle times, and accommodate unique part geometries. I am familiar with various commands and techniques, allowing me to troubleshoot issues effectively. This adaptability ensures that I can consistently meet production demands while maintaining high-quality standards. 10. Describe how you would adjust offsets for tool wear or dimensional drift during a run. When I notice tool wear or dimensional drift during a run, I first pause the machine to inspect the affected part. I measure the dimensions using calibrated tools to determine how much adjustment is needed. Based on my readings, I will adjust the offsets in the CNC program accordingly, either by increasing or decreasing the values based on the wear observed. After making adjustments, I run a test piece to ensure that the new offsets correct the issue. Once verified, I resume production and keep an eye on the process to ensure consistent quality. 11. What inspection tools and methods do you routinely use? Micrometers, calipers, gauges, CMM, etc. I routinely use a variety of inspection tools, including micrometers for precise measurements of small parts, calipers for measuring external and internal dimensions, and gauges for checking tolerances. I often employ dial indicators and height gauges for setup verification and part alignment. For complex geometries, I utilize a coordinate measuring machine, CMM, to ensure accuracy against CAD models. Visual inspections are also a key part of my process, allowing me to identify any inconsistencies before moving forward with production. Each tool plays a vital role in maintaining high-quality standards. 12. Can you walk through your process for inspecting a finished piece against technical requirements? To inspect a finished piece against technical requirements, I start by reviewing the engineering drawings and specifications to understand the tolerances and critical dimensions. Next, I gather the necessary inspection tools, such as calipers and micrometers. I then measure each critical dimension and feature, ensuring they fall within specified tolerances. I document my findings meticulously, noting any deviations. If there are discrepancies, I analyze potential causes and make adjustments if possible. Finally, I compile an inspection report to communicate the results, ensuring compliance with quality standards. 13. Have you worked with a coordinate measuring machine, CMM? If so, how did you use it in your workflow? Yes, I have worked with a coordinate measuring machine, CMM. In my workflow, I utilize the CMM primarily for quality control and inspection of critical dimensions on machined parts. After completing a batch, I load samples onto the CMM to ensure they meet the specified tolerances. I input the necessary measurement programs, which guide the machine in taking precise measurements. This data allows me to identify any deviations from specifications early, helping to maintain quality and reduce scrap. Using the CMM also aids in troubleshooting issues with the machining process, ensuring continuous improvement. 14. Describe your approach to maintaining quality and minimizing scrap in a production environment. Maintaining quality and minimizing scrap starts with thorough setup and calibration of CNC machines. I ensure that all tools are sharp and correctly installed to prevent defects. During production, I closely monitor the machining process, making real-time adjustments based on inspection results. I regularly inspect parts using precision measurement tools to catch any discrepancies early. Implementing a feedback loop with team members allows us to learn from any issues, refining processes and reducing waste. Continuous training and adherence to best practices also contribute significantly to maintaining high standards. 15. What is the most challenging part or product you have machined, and how did you handle it? One of the most challenging parts one machined was a complex aerospace component with intricate geometries and tight tolerances. The design required multiple setups, and I had to ensure that alignment was perfect for each operation. I approached this by thoroughly planning the machining process, using precise fixtures, and verifying every setup with dial indicators. I also conducted frequent inspections during machining to catch any potential issues early. This attention to detail and proactive monitoring allowed me to successfully complete the part to specifications without any rework. 16. Tell me about a time you identified a machine or process problem. How did you resolve it? In one instance, while operating a CNC lathe, I noticed inconsistent surface finishes on the machined parts. I hypothesized that the issue could be due to tool wear or incorrect feed rates. First, I stopped the machine and inspected the cutting tool, which showed signs of dullness. I replaced the tool and recalibrated the feed rates based on the material specifications. After running a test piece, I confirmed that the surface finish improved significantly. I documented the findings and implemented a more frequent tool inspection schedule to prevent similar issues in the future. 17. Have you ever had to modify a CNC program to address an issue or improve efficiency? Yes, I have modified CNC programs to resolve specific issues and enhance efficiency. For instance, during a production run, I noticed that the cycle times were longer due to unnecessary tool changes. I analyzed the program and consolidated operations, which reduced the number of tool changes required. Additionally, I adjusted the feed rates based on the material being machined, which improved the speed without sacrificing quality. These modifications not only optimized the workflow but also resulted in a significant reduction in production time, demonstrating my ability to adapt programs for better performance. 18. How do you respond to tight deadlines and pressure in a fast-paced manufacturing setting? In high-pressure situations, I prioritize effective time management and clear communication. First, I break down tasks into manageable segments and set realistic milestones. Staying organized allows me to focus on one task at a time without feeling overwhelmed. I also maintain open lines of communication with my team, ensuring everyone is aligned on priorities. If unexpected issues arise, I assess their impact and adjust plans as necessary. Staying calm and composed helps me think critically and make informed decisions, ultimately ensuring I meet deadlines without compromising quality. 19. Describe a situation when you had to adapt quickly to a new machine or process change. In my previous job, we introduced a new CNC machine with advanced features that differed significantly from our existing equipment. During my first week of training, we encountered a production deadline that required immediate use of this new machine. I quickly familiarized myself with the machine's controls and programming interface by studying the manual and seeking guidance from seasoned operators. Within a few hours, I successfully set up the machine and completed the first batch of parts. This experience taught me the importance of flexibility and proactive learning in a fast-paced environment. 20. How do you ensure safety, both personal and workplace, when operating CNC machines? Ensuring safety when operating CNC machines involves several critical practices. First, I always wear appropriate personal protective equipment, PPE, such as safety glasses, gloves, and hearing protection. I conduct a thorough pre-operation inspection of the machine, checking for any potential hazards or malfunctions. Additionally, I adhere strictly to established safety protocols, including lockout, tagout procedures during maintenance. Regularly participating in safety training and drills helps reinforce safe practices. Lastly, maintaining a clean and organized workspace reduces the risk of accidents significantly. 21. What protocols do you follow for machine and workplace maintenance? In my role as a CNC machinist, I adhere to a strict maintenance protocol that ensures machines operate efficiently and safely. This includes daily inspections for wear and tear, checking lubrication levels, and cleaning machines to prevent debris buildup. I follow a scheduled maintenance plan that involves more in-depth checks, such as examining belts, bearings, and electrical components. I document all maintenance activities and report any issues immediately to my supervisor. This proactive approach helps minimize downtime and enhances productivity in the shop. 22. How do you communicate issues, progress, or concerns to supervisors and teammates? Effective communication is vital in a CNC machining environment. I ensure that I am clear and concise when discussing issues or progress with my supervisors and teammates. I prefer to use regular check-ins or updates to keep everyone informed, particularly if there are changes in timelines or unexpected challenges. When addressing problems, I present the situation factually, including potential solutions, which encourages collaborative problem-solving. I also value open dialogue and actively listen to feedback from my peers, as this fosters a supportive team atmosphere. 23. Have you ever helped train or mentor a new machinist? How did you approach it? I have had the opportunity to train new machinists in my previous role. My approach focuses on creating a supportive learning environment. I start by assessing their current skills and knowledge, tailoring the training to their specific needs. I provide hands-on demonstrations, guiding them through the setup and operation of CNC machines. I emphasize the importance of safety and quality control throughout the process. Regular check-ins help me gauge their progress and address any questions they may have, ensuring they feel confident and competent as they develop their skills. 24. What steps do you take to keep your skills and knowledge up to date with new machining technologies? To keep my skills and knowledge current, I regularly participate in online courses and workshops that focus on the latest CNC technologies and software advancements. I also attend industry trade shows and networking events where I can connect with other professionals and learn about emerging trends. Subscribing to relevant industry publications and forums helps me stay informed about best practices. Additionally, I often experiment with new tools and techniques in the shop, allowing me to apply what I've learned in a practical setting. Engaging with peers for knowledge sharing is invaluable to my growth. 25. How do you handle receiving feedback or criticism from quality assurance or supervisors? Receiving feedback is an essential part of professional growth. I approach it with an open mind, viewing it as an opportunity for improvement rather than a personal attack. When I receive criticism, I actively listen and ask clarifying questions to fully understand the concerns being raised. I take notes during these discussions to ensure I can refer back to them later. After reflecting on the feedback, I implement the necessary changes and monitor my progress. This proactive approach not only helps me grow as a machinist but also fosters a positive relationship with my supervisors. In the world of CNC machining, being well prepared for interviews can set you apart from the competition. The top 25 interview questions and their answers provide a solid foundation for showcasing your skills and knowledge. By understanding these key concepts, you'll be better equipped to impress potential employers and land your desired position. We hope this guide helps you on your journey to becoming a successful CNC machinist. If you found this video helpful, please give it a like and subscribe for more valuable content. Your support makes a difference.